Okay, so today we're doing parametric and polar coordinates. So I'm just going to go through this really quick. The learner will convert parametric and rectangular equations. Normal rectangular equations have an input to output connection. So input to output. For example, when y equals x squared, when we plug in a number for x, it changes y. This implies that y only moves because of x. But there could be some hidden factor that is changing them both. For example, a convenience store notices that every degree above 70, the store sells X bottles of sunscreen and X squared pints of ice cream. So we could write an equation that looks like ice cream equals sunscreen squared. Okay? The equation is true for the data, but doesn't make sense. Okay? Could there be a hidden variable that changed them both? Like temperature. So temperature is what you would put there. So it would be better to write the two separate equations. Sunscreen equals the temperature minus 70, and ice cream equals the temperature minus 70 squared. Okay? Temperature is the parameter. Parametric equations get us closer to the real world relationship. Parameters point to the cause. Why did we change time, temperature, or maybe sunscreen? Okay? All right, so here's the formula. And I'll post these notes completed out on the Google Classroom for y'all. So if two related variables depend on the third variable, t, then x is some function of t and y is some function of t are parametric equations. T is the independent variable and is called the parameter. Okay, so a golfer hits a golf ball with an initial velocity of 130 feet per second and a 45-degree angle of elevation. The following parametric equations model the path of the ball. Okay? So, all you do is you put some numbers in here for t. So, 0, 1, 2, 3, 4, 5. So this is your t. Okay? And then you have your x, and then you have your y. All right. So, what happens when t is 0 in the first equation? You get 92 times 0, which is 0. What about when t is 1? 92 times 1 is 92. 92 times 2, 184, and so on. Again, all I'm doing is I'm putting these numbers in this t. Okay, and that's giving me the x values. All right, so now let's do the y values. So negative 16 times 0 squared plus 92 times 0 is just 0. When I put a 1 in here, I get negative 16 times 1 squared, which is negative 16, plus 92 times 1, which is 76. Okay? And then you just put the 2, 3, 4, and 5 in for t. And so I get 120, 132, 112, and 60. Okay? So, make a table. We did that. Then plot the points from the table onto the graph. Well, it's going to do... Here, I'll just go ahead and make the graph. It's going to go up like this. Okay? And it says put some arrows on here, so goes like that. And the graph should be X and Y. So X and Y, I believe. Yeah. So it's X to Y, and T is not on here because this is just how X compares to Y. Okay? Alright, so let's move on. Okay, your T is just to get the values of X and Y. Okay? Okay, for each pair of the following parametric equations, make a table of values. Draw the graph and show the orientation, right? The rectangular equation. Okay? So let's make a table again. Zero, 1, 2, 3, 4. Okay, so what we're going to do is, same thing we did on the last problem. We're going to put, this is where the 0, 1, 2, and 3, and 4 came from. Okay, so put your 0 in here. X equals 1 minus 2 times 0, which is just 1. Okay? X equals 1 minus 2 times 1, which is negative 1. And then you get negative 3, negative 5, and negative 7. Okay? So now put in 1 for this equation. Y equals 2 plus 2 times 1. So the first, 0. Y equals 2 plus 2 times 0. So that's just 2. And then 4. And then it should be 6, 8, and 10. Okay? So now